Alright, I apologize for the audio. I know it sounds a little crinkly, like, I don't know, something's wrong with the speakers a little bit, but I got my trusty calculator here. See if I need it. Now, at first, I'm dealing with arc length, and then I'm going to find the area of a sector, and these guys are just formulas. Formulas are all over in your life. Let's see, are these double-sided here? Yes, so I will write on the front side in pencil. So our first one is oh, I'm sorry. Ooh, I was confusing it with algebra. Okay, or maybe you saw it like this. I can't remember how we wrote it. Either way, multiplication is commutative, so we can change the order of this, and it's no big deal. I think it's actually the second one. But this arc length equals theta times r. Now the reason why theta is important here is it's got to be in radians. Otherwise, our formula gets a little bit more complex. We'd have to convert it to radians. So, engineers, mathematicians like to use radians because it's just it's already kind of got the formula embedded in it. So theta is pi over 4, which is 45 degrees, times 9. So it looks like we get 9 pi over 4, and we just kind of leave it like that because we don't have to. We don't have to do anything. Now, we could figure out what this is in decimal, but that's perfectly sufficient. All right, this guy, same thing. We've got 7 pi over 6 times 5, so that's going to be 35 pi over 6. That doesn't reduce anywhere, and that's going to be in meters. Okay. This guy right here is 90 degrees, but he's not in radians, and I know that 90 degrees is actually pi over 2, so I can just convert that quickly because that's the benefit of knowing your unit circle. And times 17, so that's going to be 17 pi over 2. Okay, and that'll be in centimeters, so that's that right there. Okay. Then we've got 120. So 120 is 60 degrees off of that. That is actually 2 pi over 3. Okay. So you can look that up, or you can convert it. One of the things you could do is just go, do that. And then you'll notice that 60 goes in there twice, and it goes in there 3 times. You get 2 pi over 3. Okay. So having that unit circle memorized is kind of nice. Okay. But this guy goes into there 3 times, so it looks like we get 6 pi. And it'll be in feet. All right. So now the formula of the sector gets a little bit more complicated, but not much. Here we've got the area equals. Now we're dealing with the area. Okay. A sector is an area of a portion of a circle. So this guy is 1/2 radius squared times theta. Okay. So we're going to go 1/2, and the radius is 9. We're going to square that guy, wrap him up in parentheses, and 5 pi over 4. All right, that's going to be 81 times 5. So 81 times 5 will go in the numerator, and then we're going to be dividing that by 8. So 405 pi divided by 2 times 4, which is 8. Okay. That's our answer. This guy over here, 5 pi over 4. Don't forget, 1/2. And then the radius squared, which is 144. Okay. So 144 times 5. Let's see, 4 will go into 144 for sure. Does 8? 8 does. So 8 goes into 144. 18 times. So that's 18 times 5. And what is that? 80. 40. So it's 90. 90 pi. And that's in inches. Okay. And now we're in radians. And I'm sorry, degrees. So now we go 1/2 r squared times pi over 2. Okay, I had to convert it to radians. I'm going to convert this guy to radians as well. And I get 64 pi over 4. And 4 goes in there once, and then 4 goes in there twice, 6 times. So I'm getting 16 pi, and I don't see that there, so this is a none of these. Okay, I'm feeling pretty confident with that answer, so I'm going to go ahead and not look at it again and know it's none of these. This guy here, the area is 1/2 times the radius squared times theta. Now 270 is 3 pi over 2. Okay, so now I'm going to go ahead and put, let's see, 15 times 15. I'm going to actually use a calculator. I always wanted to have my multiplication tables memorized up until the 15s, but that guy times 3 is 675, okay, pi over 4, and it looks like that doesn't reduce, so we'll go with that. All right, and it's square miles. Okay, that whole area is in square miles. All right. Okay, now that's, I would probably say, the long part there. Okay, so now converting these guys, we've got decimal, and we want to convert it to minutes. We know that it's got to be 109 degrees, so what do we do with the 0.7? So the 0.7, what we do is we figure out, okay, well, 0.7 of 60, so let's take 0.7 and multiply that by 60, and we get exactly 42. There is no remainder on this guy. So this means it's got to be B, because we're not going to have any seconds whatsoever. Okay, so this is our answer there. All right, now we got point. Now it's going to be 107, but now it's going to be 0.9525, and I want to multiply that by 60, and it looks like I get 57. Okay, so it's got to be 57. But I will tell you on the quiz it'll be a little harder. Let's see where this 9 comes from. We take the 0.5 and multiply that by 60, and that's where the 9 seconds comes from. Okay, so we take the remainder of that decimal and multiply it by 60 to figure out what portion of 60 seconds that 0.15 is. Okay, there we go. Yes, their practice test is due. The videos are posted for their solutions, and they'll be taking their test on Thursday. Their practice test is due on Thursday. Oh, shoot. Okay, I just texted. Sorry. Just skip over this part of the video. I just got a text from Mrs. Wagner. Okay, so let's see. Now we got this guy. So this is going to be 113 plus 53 over 60 plus 24 over 3,006. I keep getting text. Sorry. So whatever that is, it's going to be this in decimal. Okay, so let's see here. We're going to go 113 plus 53 divided by 60 plus 24 divided by 3,600. Now we've got to do this because this is the portion of what seconds are for a complete degree. Now it should give me decimal, and that's great. So I do get 0.89, and that's exactly what we get. Okay. So we're going to do the same thing here, plus 21 divided by 60. Notice I don't have to do any parentheses because the order of operations is going to do the division for me. Okay, just make sure that you don't divide, make sure you don't divide the 36 by 60. Okay, it's just the way that all of this works, and this is a none of these. Okay. All right, so now find the value of the trig function indicated. Well, if we're going to go cosine from here, cosecant. Cosecant is actually 1 over sine. So this means what used to be O over H is now H over O. So take a second to just figure that out. And H here is 25, and 25 over O is going to be over 20. So that's 25 over 20. And let me just slow down for a second. Before we do these, it's good to label these as what you have. Okay, so the hypotenuse is 25, opposite is 20, adjacent is 15, and so now that you got them all labeled, you can get any trig function you want, and this ended up being 25 over 20, so that would be 5 over 4 once you reduce the fraction. All right, so let's label these again. Okay, this is O, this is the H, and this is the A, and we know that tangent is O over A, and so that's going to be 15 over 20, okay, and that's going to be 3 over 5. Alright. Alright, sine, let's see, we've got O over H. Oh, great, that's exactly what we needed. So we have 7 over 17 radical 2. Now, we don't actually see that answer. Now, this looks like it, but why is it not? Well, we're going to have to multiply by radical 2 here, okay, in order to get rid of the radical. So that does give us 7 radical 2 over there, and then this will be radical 4, which ends up being 2. 2 times 17 is 34. So actually, it's not this guy at all. It's this guy. So watch out for that. Okay. All right, cotangent here. Let's see. We've got O, and that's the H, and we need the A for cotangent because cotangent is A over O. All right, now because that's the case, I'm going to have to figure out using the Pythagorean theorem, okay, of the hypotenuse minus the side, okay, both squared, and that's going to equal the adjacent squared. I need the adjacent, okay. So what I'm going to do is I'm going to figure out what 17 squared is, okay, and then I'm going to subtract 15 squared, okay, and I get 64, and the square root is 8. Okay, cool. So it looks like this guy is 8. So A over O is going to be 8 over 15. Okay, 8 over 15. All right, and that's this guy here. I can actually write him a little darker now. Okay, so here, what are we at? 11 mark? Yeah, I'll stop right here at 18. Find the measure of this guy. So we need him. It's a new pen. All right, we need this guy. We have this in degrees, so make sure your calculator is in degrees. Mine is in radians, so I will have to go mode and push it over to degrees, and then second mode quit. All right, and what I need is an O, and this is an A, so the hypotenuse is not given to me, so I need to use tangent. The tangent of 39.8 degrees equals O, which is x, over 9. All right, now we cross multiply here, so 9 times the tangent of 39.8 degrees equals x. So whatever this guy is, make sure again that he is in degrees times the tangent. Can't see. It looks a little out of focus to me. Okay, that looks a little sharper. 39.8 degrees, and we've got 7.49, which is 7.5. Okay. All right, next we've got this angle right here. This is A, and that is H. So the only cosine ratio that uses A and an H is cosine. Okay. So does secant, but secant doesn't have his own button. Okay. So cosine of 60 has to equal A over H. Okay, and we'll just put the H there. So the H, X, and it's okay. 6 divided by the cosine of 60. Okay. Now actually the cosine of 60 is 1/2, and so the answer here is actually 12, but let's verify that. Okay, and then again, that's the benefit of knowing your unit circle. Okay, 12. So we're right there. Okay, because I remember that's 1/2. All right, and we'll stop there.